Hi friends, let's solve this problem. If square bracket x is the greatest integer less than equals to x, it's the greatest integer function. So then pi square integral 0 to 2 sine of pi x by 2 into x minus greatest integer function of x, the whole raised to greatest integer function of x dx is equals to, we have to find the value of this integral. So as it contains the greatest integer function x and we have an integral running from 0 to 2, so we know that the answer is 0 for 0 less than equals to x strictly less than 1, and the answer is 1 for 1 strictly less than x less than equals to x and strictly less than 2. Okay, so now let's start with our integral. So we have pi square integral 0 to 2 sine of pi x by 2 into x minus greatest integer function of x, the whole raised to greatest integer function of x dx. Okay, so now let's calculate value of this integral. So now we separate this integral 0 to 2 as from 0 to 1 plus 1 to 2 by using definite integral properties. So we have pi square integral 0 to 1 sine of pi x by 2 bracket, then here we have from 0 to 1 this greatest integer function is nothing but 0, so this is into 0. Okay, then we have dx plus, so now this is equals to pi square integral 0 to 1, then we have sine of pi x by 2. Okay, then this is x minus, this is 0, so it's a x minus 0, it's an x from 0 to 1, this integer part of x is 0, then it's an x raised to 0, so it's going to be 1. So now this is into dx plus pi square integral 1 to 2 sine of pi x by 2. Now it's an x minus greatest integer function from 1 to 2 is 1, so we have x minus 1 raised to, again greatest integer function value is 1, then dx. Okay, so now the first integral it's easy. For the second integral we have to apply u into v rule. So now this is equals to pi square, then sine integration is minus cos of pi x by 2, then it's upon pi by 2, so it's into 2 by pi, upper limit is 1, lower limit is 0, plus then it's a pi square, then we are taking x minus 1 as a u, this we are taking it as a u and this is as a v, so it's a u integration of v, so integration of sine, it's a minus cos of pi x by 2, then it's upon pi by 2, so it's nothing but into 2 by pi. Okay, then minus integration of, then minus integration of sine, so it's going to be minus cos, so this become plus, and then it's a cos of pi x by 2 again upon pi by 2, so it's nothing but into 2 by pi, and derivative of x minus 1, it's nothing but 1 dx, upper limit is 2, lower limit is 1. So now this is equals to, it's a pi square bracket, now when we put 1, so cos pi by 2, cos pi by 2 is 0. Okay, cos pi by 2 is 0, minus, then minus minus it turns out to be plus, and when we put 0, so cos 0 is 1, so it's a 1 into 2 by pi, so basically it's a 2 by pi, plus pi square bracket, now this turns out to be x minus 1 into minus cos of pi x by 2 into 2 by pi plus, now integration of this 2 by pi is constant. This 2 by pi is constant. Now integration of cos is going to be sine. So it's a sine of pi x by 2 and then again pi by upon pi by 2. So it's a into 2 by pi. Okay. This is pi. So 2 by pi. So now we have upper limit 2, lower limit 1. So now we just have to substitute the upper limit and lower limit to get the answer in the second term. So now what we get? This is equals to pi square into 2 by pi. So it's going to be 2 pi plus pi square bracket. Now when we put 2, so it's a 2 minus 1, it's a 1, and from here it becomes cos of pi. So cos of pi is minus 1. So this turns out to be plus 1 into 2 by pi. Okay, plus then if we put x equals to 2, so it's a sin pi is 0, so it's a 0 minus, let's put the lower limit. Now when we put x equals to 1, so the first term turns out to be 0, then minus of second term. So now when we put 1, so sin 90 is 1, so we get 4 by pi square. Okay, so now this is equals to 2 pi plus, then again here we get 2 pi minus, then when we multiply pi square, so we get minus 4. Okay, so then we get this as a 4 pi minus 4. So this is 4 into pi minus 1. This is the value of the integral. So now let's see which option is correct. It's a 4 times pi minus 1. So option B is correct. Okay, option B is correct. Thank you.